is a famous formula that allows you to solve any type of quadratic equation. A quadratic equation is a second-degree polynomial, which means that its highest exponent is 2. An example of a quadratic equation is x squared plus 3x plus 4 is equal to 0. You can see that the highest exponent is 2. The usefulness of the quadratic formula is seen when we have a quadratic equation that can't be solved by other methods. When other methods fail, the quadratic formula succeeds. Do your best to remember this formula. In order to use the quadratic formula, the quadratic equation must be in standard form. What does this mean? It means that your equation must be written in decreasing order, starting with the term with the largest exponent, and then going down based on the exponent. So your quadratic equation written in standard form will look like this, where a, b, and c are your values. Did you see how those letters are also used in the quadratic formula? Yes, when you write your quadratic equation in standard form, you can easily spot which value is your a value, your b value, and your c value. Once you have all three of these values labeled, you can plug these values into your quadratic formula to solve your equation. If you see a missing term, then the letter for that term will be 0. Let's try an example. Say we have the quadratic 2x squared plus 3x plus 1 equals 0 that we want to solve. We see that the equation is already written in standard form, so we can go ahead and label our a, b, and c. We compare this to the standard form, and we find that our a value is 2, our b value is 3, and our c value is 1. Plugging these into our quadratic formula gives us 3 plus or minus the square root of 3 squared minus 4 times 2 times 1 divided by 2 times 2. Once we have plugged in our values, we can now evaluate our formula to find our answer. The formula doesn't look nearly as bad now, does it? With all these numbers in place, it now looks manageable. Let's go ahead and evaluate to see what we get. We first tackle the inside part of the square root. We square the 3 to get 9. Then we multiply the 4, the 2, and the 1 to get 8. Now we subtract the 8 from the 9 to get 1. Now we deal with the denominator by multiplying the 2 and the 2 to get 4. So now our quadratic formula looks like 3 plus or minus the square root of 1 divided by 4. We see that there is a plus or minus. That tells us that we now need to split our formula into two separate formulas, one for the plus part and another for the minus part. That tells us that we will have two possible answers. We have x is equal to negative 3 plus the square root of 1 divided by 4, and x is equal to negative 3 minus the square root of 1 divided by 4. Evaluating the first, we get negative 3 plus 1 divided by 4, which is equal to negative 2/4, which is equal to negative 1/2. So negative 1/2, or negative 0.5, is the first part of our answer. The second part is x is equal to negative 3 minus the square root of 1 divided by 4, which is equal to negative 3 minus 1 divided by 4, which is equal to negative 4 divided by 4, which is equal to negative 1. So our two answers are negative 0.5 and negative 1. We are done. One thing to note here is that if the square root part is negative, then we can stop right there. Why is this? When we have a negative square root, we will get an error when we use a calculator to calculate it, so that tells us that we are dealing with numbers that aren't real. Because of this, we can stop and say that there are no real solutions. Let's recap. We've learned that the quadratic formula is this, and can be used to solve any quadratic equation. To use the formula, our quadratic equation must be in the standard form of ax squared plus bx plus c is equal to 0. Once our equation is in standard form, we compare our problem with the standard form to find our a, b, and c values. Once we have our values, we plug them into our formula and then evaluate to get our answer. If the part under the square root is negative, though, we stop and say that there are no real answers.